Hi students, let's continue with question 4. We are supposed to show that the cubical expansivity gamma of a substance is related by its linear expansivity alpha by the expression gamma equals 3 alpha. This question is simple because we've already done that of the beta equals 2 alpha. So if you understood that one, this becomes simpler. What I will do here is that I will just guide you on how to go about it. Then you prove it to me, then you let me know from your comment section. So let's start this way. So solution, that is question 4, right? So we know that from cubical expansivity, how do we define it mathematically? Gamma is change in volume, right, over initial volume times change in temperature. So when we are talking about cubical, then it has to do with volume, right? So go through the same approach I did, okay? Let's call this question 1, okay? And we said that where Vi is what? Initial volume of the solid or the substance, right? So then from equation 1, we can say that gamma is V final minus V initial over V initial times delta theta, where of course Vf is the final volume of the solid and Vi is the initial volume of the solid. Okay, great. So then we can write that when we make Vf the subject, of course it will follow the same trend. You get Vf, take your time and make it a subject, 1 plus gamma delta theta. Let's call this equation 2. All right. So this is where you continue from. Then we are assuming that from when we were doing the area after this, we assume that, so here we are assuming that the solid is a cuboid, okay? And if the solid is a cuboid, then how do we find the Vf? The Vf can be expressed as the Lf times Wf times the Hf, right? Where we know that Lf is the final length, you know already, okay? Wf is the final width, and Hf is the final height of the solid, right? Then we also know that from linear expansivity, just as I said, this one I'm not doing the real proof, I'm just doing rough guidelines for you, giving you rough guidelines. So Lf minus Li over Li, okay? So from here, what do you get for Lf? Lf will give you Li, that's not it. Then you can also express it in terms of Wf and Hf as well, okay? I hope you are enjoying. You are just following, okay? You are going to do the rest. So I have to call this equation 3. Then let me call this 4. Let me call this 5. Let me call this 6. Are we following? So we put 4, 5, and 6 into equation 3. So what I mean is that you are going to put 4, 5, 6 into equation 3. And when you put it and you beautify it, just like what I did previously, just like what we did, okay, you get your VF to be what? Li 1 plus alpha delta theta times what? Wi 1 plus alpha delta theta times hi 1 plus alpha. So here you just beautify the equations, but it's going to be cube, right? So you get Vf to be Li times what? You beautify the equation just like we did for the other one. 1 plus alpha delta theta. So look for the proof for the other one and use it to solve this one. But here it's going to be cube. Okay? Yes. So you expand this. Take your time, expand this. If you don't want to use the binomial way and you want to use this, the basic way, you can find it as this. Simplify this first, then simplify this, multiply it by this. So when you expand it, what you get, then you come and multiply it by this. Okay? Then don't forget that this one can stand for Vi. You get it? And you know that linear expansivities take, usually for solids, they take small values. So in the expansion that you will get, all the alpha, okay, all those with alpha squared and all those with alpha cube will all go to what? 0. And when they go to 0, the equation will be reduced. Then you follow the same approach. You equate that, you get two different VF's equation. You equate them and solve them. Just use the approach. It will come. Okay. After expanding this, okay, let me come again. This is Vi times what? 1 plus alpha delta theta all cube. All right. After expanding this one, this is a bit tedious, but it's not difficult. When you expand this one, what do you get? As we know, the alpha squares and the alpha cubes will go to 0. Why would they go to 0? We said that the expansivity in solids are usually small. Linear expansivities take small values. So even in questions, you realize that the powers are exponent negatives, right? Small values. So when you are squaring and cubing them, you'll be getting negligible values. They don't add any much value to the work. So you can approach them, you can assume them to be 0, and it will reduce the equation. To reduce your equation. And that one will let you get your VF. Your VF will be so simplified. Then you come and compare after simplifying this one, what you get. Letting this one get to 0. Then you can come and equate that VF with this VF. Where is it? You can come and equate it with this VF, with this equation 2 VF. Yes. And when you simplify it, your answer will come. Your answer will come. This is our focus. Let me show you our focus. Yes. Your answer on this one will come. You get this. I'll be waiting for you. All right. Thank you.